This is section 2.1 for college algebra, equations of lines. Some of these might be pretty familiar to you and some may be a little bit new. Let's go over the main ones that we'll be covering in this section. Point slope is the first one, and here is the form of the equation. Y minus y1 equals m times x minus x1, where your x1, y1 is your point that you're given and m is your slope. Slope-intercept, you're probably most familiar with. Y equals mx plus b, where m is your slope, b is your y-intercept. The next one is horizontal lines. That equation is y equals b, so it would be y equals a number. And remember that that is a horizontal line going through whatever this b value is on the y-axis. A vertical line is x equals a, vertical line going through a value at a on the x-axis. The next ones that we'll look at will be parallel and perpendicular lines. For parallel lines, they do go the same direction, and so their slopes are equal. m1 equals m2. Perpendicular intersect at right angles. Their slopes are negative reciprocals. You might remember this by saying flip and change the sign. Examples of that would be, if you're given that one has a slope of 1/3, then the perpendicular line would be negative 3/1. You flip it and change the sign. The parallel to that would be 1/3 because it's the same. If you're given a slope of 8, parallel to that would be 8. Perpendicular, flip it, 8/1 becomes 1/8 and change the sign. Same thing here, y equals negative 1/4 x plus 8. Parallel line to that would have a slope of negative 1/4, which is the same. Perpendicular, flip that, you get 4/1, make it positive. The other thing that is here is something about correlation coefficients. This has to do with linear regression, and we're gonna cover that in this. And if you have your diagnostics turned on in your calculator, in other words, if you go, we're not going to do that right now, we'll do that in the homework, but you'll get some r values, some r squared values in your information when you create your equation. And what we need to know is that that correlation coefficient, that r value, is really going to tell you how close you are to being a perfect fit. If r equals 1 or negative 1, then your line, your equation that you've come up with, or that the calculator has come up with, is a perfect fit. It hits every dot. And this one's positive because it's positive slope. That's a positive 1. This would be a negative 1. It's a negative slope. If r is a fraction, it would be a decimal on your calculator, between 0 and 1, so a positive fraction. That means it is positive slope, and you know, they're in there somewhere. Some of them might hit, some of them don't. It's going in the general direction. If it's between 0 and negative 1, it's a negative slope. Same thing, not a perfect fit, just hitting some of the dots, not all of them. And then if r happens to be 0, it means there is absolutely no correlation. There's no tendency toward being linear. All right, so we'll see that in one of our homework questions, so you'll have that to refer to. Let's look at the problems. All right, in number 1, write an equation for the line shown. All right, so this is what you would have. You would just have a line shown there, and you have 2 dots here. So we have to figure out 2 things for writing the equation of a line. We need to know the y-intercept if we can. So that in this particular one is at what? Okay, the y-intercept here is at y equals 7. So we have b equals 7. The slope we figure out by how many did we go down and how many did we go over. If we go down, it's always a negative. All right, so we went down 11 units and we went over 3 units to get to this point here. All right, so our slope would be negative 11 thirds. All right, and so we can write that in our equation, y equals negative 11 thirds x plus 7. On number 2, find the slope-intercept form for the line containing the following conditions. Slope of 4, wrote that here, and here's your point 0, 3. So we use our point slope form and plug in the parts. Y minus 3 equals 4 times x minus 0. So that's y equals 4x, and I added the 3 to the other side. Same thing with this one. We have to determine the y-intercept, which is at 5. So b equals 5 there. And then to get to this point over here, we went down 2 over 7. So m is negative 2/7. Put that in the form of the equation. And it does tell you what form that your answer should be in, so be aware when it asks for those. All right, this one is wanting slope-intercept. Our y-intercept is 7, and we went down 13 and over 6. Negative 13/6 is our slope, so we have our equation here. All right, match the equation. Y equals b. Remember, that's a horizontal line, and it says b is greater than 0. So it has to be a positive. It has to be up here above the x-axis. So it can't be this one. We know it's not vertical. It's got to be this one. Find an equation for a linear function parallel to the given line and passing through the given point. So you look at the line that you are given, and the slope of this line's 4. So if we're writing one parallel to that, our slope is also 4. The point that you're given, this 0, 5, we need to recognize if you have a 0 for an x value, you have the y-intercept. So the point given is the y-intercept, which would be 5. All right, so we have y equals 4x plus 5. In this one, we want a line that is perpendicular to this given line. So here's our given one. And the slope of the given line is 3/2. Perpendicular to that would be, we flip it and change the sign, so we have negative 2/3. So we're going to plug in the parts that we are given. We're going through this point at 2, 3. So here's our x1 and here's our y1. So y minus 3 equals negative 2/3, here was your m, times x minus 2. This one, I don't think I have the directions printed there, but I believe that is in slope-intercept form as well. Y minus 3 equals, now we need to distribute, so we have negative 2/3 x plus 4/3. Negative times negative gave us 4/3. So we need to add this 3 to the other side, and then I showed you that the 3 is equal to 9/3. 3 over 1 is equal to 9 over 3. Whenever I teach that, it's always a backward z, and I say 1 into 3 is 3, 3 times 3 is equal to 9. So when you have 9/3 here, 4 and 9 is 13. So you have negative 2/3 x plus 13 over 3. They want an equation of a line that is vertical and passing through this point. Well, remember the equation of a vertical line is x equals a number. Which one is the x coordinate? 3. So x equals 3 is our answer. All right. In 1994, the life expectancy of males in a certain country was 69.4. In 1998, it was 73.3. E represents the life expectancy in year T, and let T represent the number of years since 1994. since 1994 is important. So we need to figure out the slope, and we're given essentially 2 points. 1994 was 69.4, and 1998 it was 73.3. The x value is the years, because t is letting it be the years, and we're calling that's the same as our x value. All right, so it says after 1994, so we let 1994 be 0, and then from 94 to 98 is 4, so we have 0 comma 69.4, 4 comma 73.3. Those are our 2 points. I'll write those over here. All right, so let's find the slope using those 2 points. So here we subtracted the y's and subtracted the x's or the t's, and we got 39 over 4, which is 0.975. And we're asked to put this function here. Well, we should note, first of all, that the 0 comma 69.4, that's our y-intercept because the x value is 0. So 69.4 is going in this box. And our slope is 0.975, but it does say round to the nearest tenth, so that would be 1.0t. So 1.0 is going in this box. All right. Then it asks for, well, what's e of 10? That's like saying, what's f of 5? That means we plug in 10 to the equation that we just wrote. So if you plug in 10, you've got 10 plus 69.4, which would be 79.4 would go in this box. Okay? All right, number 10. A person's driving a car on a straight road. The graph shows the distance y in miles that the individual is from home after X hours. Okay? We need to note the scales here. This is going by 1, but this appears to be going by 40s. And so in here, this would probably be 10, 20, 30, 40, I would suspect. But anyway, find the slope-intercept form of the line. Well, we have 2 points. We need a slope. Here's 1 point. Here is the other point. Let's find the slope. We subtract the y's, subtract the x's. We get 25. Now we'll pick a point and put it in the point-slope form. You could use either one. I always like to use something that has 1 in it. That's easy to play with. So we're going to put y minus 35 equals 25 times x minus 1. That gives us y minus 35 equals 25x minus 25. Add your 35 to the other side and you get 25x plus 10. So that is going in these boxes here, get the 25 and the 10. So it's saying, how fast is the car traveling? What are the miles per hour? That's your slope. That would be 25. How far was the individual from home initially? Remember that y-intercept is about initially. That's where you start. And so that would be the 10. So you get both that from that problem. How far was the individual from home after 3 hours and 15 minutes? 15 minutes is a quarter of an hour. So we're going to use 3 1/4 because this is in hours. So you plug in 3 1/4 for x and solve that, and you should get 81.3. It does say do an integer or a decimal, not fractions. So 81.3 goes there. All right, 11 brings us to our regression question. All right, so this one says, find the line of least squares fit for the given data points. What's the correlation coefficient? And plot the data and graph the line. So we need to look at this. You have some, let me clear this so that we can do this together. You have a set of handouts, and in the handouts there is a paper on regression that has the steps for doing the regression. It does not talk about the correlation coefficient, so we will cover that. But if you need to refer back to that handout, do that to help you. All right, so the first thing we want to do is make sure that the correlation coefficient is going to print out for us. We're going to do that by going to second catalog, so that's second 0, and then we want to look for diagnostics. Look at your little alphabet up here in the green on mine. It has the letters. So here's D above the X inverse key. Hit that and it will take you to the D's. Then we're going to scroll down till we come to diagnostic. Okay, I'm going back up, and I want to make sure they're on, so I will hit enter and enter. Okay, so I've turned those on, so that's what I need to do. That's what you need to do for this question. All right, next thing we need to do, we need to go to y equals, clear everything that's in there, and we want to jump up where it says plot 1 and hit enter. That's a shortcut to turn on the stat plot. All right, we'll go to stat and enter, and I've got some stuff in mine. You might have stuff in yours, and we're going to clear those columns. Jump up on L2, hit clear and enter. Let's do the same thing over here. You don't want to hit delete because you'll get rid of the column completely. Clear and enter. All right, in L1 we're going to put our X values. So we're going to put -4, enter, 1, enter, 5, enter. All right, we'll go over here and put our Y values. So that'll be 6 and 0 and -4. All right. Then we always do a zoom 9. It's a statistical window. Did that not do it? Zoom 9. Let me check something real quickly. Okay, let's try that again. Zoom 9. I just was expecting a little bit different window, but we will go with that. So you get some dots, and it says what's the line of least squares fit for the given data points. You will go back to stat, over to calc, and we want to choose linear regression, and we'll hit enter, and we'll hit enter. All right, so I put this screen right here. If you'll notice, here's our equation parts. Here's our slope, -0.114. This does say round to the nearest thousandth, I believe. Yes, so 3 decimal places. So -1.114 x plus 1.409, it rounds to 410. So here is the equation that will go in your boxes. What is the correlation coefficient? That is R down here, okay? And it is -0.999. So I don't have my negative there. All right, -0.999, which makes sense. Our equation, our line had a negative slope. It's very close to being perfect. It's not quite there. All right, so that's that. And choose the correctly plotted data and graphed line. We can bring that line in. If I go to vars, y vars, let's see, let's go to y equals and go to vars. Number 5, statistics, over to equation and enter. And I believe it brought it in for us. And let's hit graph. Okay. Now they look a little bit alike. Let's change the window to match these, and let's have a -5 here and an 8 here. Y-min -5 and 7. Let's just see if that gives us a little bit better picture. I added the grid to mine. If you wanted to do that, you could do second format, and that's where you can do that. This is really a little bit tough to figure that out. One of the things, I got rid of this one because my line goes through that point, so that one's gone. This A and C look very, very much alike. This is going to be a tough question, but I believe it is C is the correct answer. So that helps you with the regression, and that should get you through the problems on section 2.1.